Now come to the proof. Given that f and g be integrable functions on the closed interval ab, therefore by the theorem a bounded function f on the closed interval ab is integrable if and only if for each epsilon is positive there exists a partition P of the closed interval AB such that the difference of upper Darboux sum of the function f corresponding to the partition P and the lower Darboux sum of the function f corresponding to the partition P is less than epsilon. Let epsilon be positive. There exists partition P1 and P2 of the closed interval AB such that the difference of upper Darboux sum of the function f corresponding to partition P1 and the lower Darboux sum of the function f corresponding to partition P1 is less than epsilon by 2. And for the partition P2, the upper Darboux sum of the function g corresponding to partition P2 and the lower Darboux sum of the function g corresponding to partition P2, its difference is less than epsilon by 2. Therefore, by the lemma, let f be a bounded function on the closed interval AB if P and Q are partitions of the closed interval AB and P is subset of Q, then lower Darboux sum of the function f corresponding to partition P is less than equal to lower Darboux sum of the function f corresponding to partition Q, which is less than equal to upper Darboux sum of the function f corresponding to partition Q is less than equal to upper Darboux sum of the function f corresponding to partition P. For P equal to P1 union P2, then upper Darboux sum of the function f corresponding to partition P and the lower Darboux sum of the function f corresponding to partition P is less than epsilon by 2. Its difference is less than epsilon by 2. And the difference of upper Darboux sum of the function g corresponding to partition P and the lower Darboux sum of the function g corresponding to partition P is less than epsilon by 2. Therefore, for any subset S of closed interval AB, we have the infimum of the function, the sum of functions f of x plus g of x, where x lying between the set S. There is greater than infimum of the fx, the set, infimum of the set, functional set f of x, x belongs to the set S, and the infimum of g of x, x belongs to S. We write infimum, that is m, f plus g of s corresponding to the set S is greater than the infimum of the function f corresponding to the set S and infimum of the set g corresponding to the function S. That implies the lower Darboux sum of the function f plus g corresponding to partition P is greater than equal to lower Darboux sum of the function f corresponding to partition P plus lower Darboux sum of the function g corresponding to partition P. And similarly, we have upper Darboux sum of the function f plus g corresponding to partition P is less than equal to upper Darboux sum of the function f corresponding to partition P plus upper Darboux sum of the function g corresponding to partition P. So we have minus lower Darboux sum of the function f plus g corresponding to partition P is less than epsilon. So f plus g is integrable. And since integration from a to b f plus g equal to upper Darboux sum of the function f plus g is less than equal to upper Darboux sum of the function f plus g corresponding to partition. Since integration from a to b f plus g equal to upper bound of f plus g is less than equal to upper Darboux sum of the function f plus g corresponding to partition P, which is less than equal to upper Darboux sum of the function f corresponding to partition P plus upper Darboux sum of the function g corresponding to partition P, because the difference is less than epsilon. Upper Darboux sum of the function f corresponding to partition P minus lower Darboux sum of the function f corresponding to partition P less than epsilon by 2. This assertion gives us lower direct proximity of the function f corresponding partition p plus lower direct proximity of the function g corresponding partition p plus epsilon. That implies lower bound of f plus lower bound of g plus epsilon. That is integration from a to b f plus integration from a to b g plus epsilon. The first assertion. And integration from a to b f plus g equal to lower bound of f plus g is greater than equal to lower direct proximity of the function f corresponding partition p is greater than equal to lower direct proximity of the function f corresponding partition p plus lower direct proximity of the function g corresponding partition p, which is greater than upper direct proximity of the function f corresponding partition p plus upper direct proximity of the function g corresponding partition p minus epsilon. From this, plus epsilon by 2 plus epsilon by 2, in this way we got minus epsilon, which is greater than upper bound of f plus upper bound of g minus epsilon. The integral from a to b f plus integration from a to b g minus epsilon. We got second assertion. From first and second, we got integration from a to b f plus g equal to integration from a to b f plus integration from a to b g.